Hello guys, welcome to all of you once again. So first of all, let me give you a brief introduction about this video. What I have done today is I have compiled all your physics formulas together so that you could revise it in a very short interval of time. Since your exams are very near, that's why I thought to do this. And what is your work is to just revise these formulas again and again, ताकि अपने आपके माइंड में ये फॉर्मूला सारे अच्छे तरीके से एंटर कर जाए, सो डैट अगर कोई भी क्वेश्चन, इफ एनी टाइप ऑफ क्वेश्चन दैट इज दे आर आस्किंग डायरेक्टली फ्रॉम फॉर्मूला, तो आप उसे कर सको. सो लेट्स स्टार्ट आवर क्लास. The first chapter of physics is our measurement and units. First is measurement and units. In this chapter we have very less formula. This is mass, quantity I have taken here, time, this is length, SI unit. SI unit of mass is kg, this is second, and this is meter. This is very simple. Second concept we have time period. Represented by t, and the formula for t is 2 pi root over L by G, where L is your length and G is gravity. That is 10 meter per second square. Third one is we have density, represented by rho is equals to mass upon volume. Mass is in kg and volume we will have in meter cube. Volume we will take in meter cube if a mass we have taken in kg. So SI unit of density is SI unit of density equal to kg per meter cube. Then these are some units. 1 kg is equals to 1000 gram. 1 kilometer is equals to 1000 meter. 1 meter equal to 100 centimeter. 1 micrometer equal to 10 to the power minus 6 meter. 1 nanometer is equals to 10 to the power minus 9 meter, and 1 angstrom is equals to 10 to the power minus 10 meter. These are some of the important units that I have taken. Now we have chapter number 2, forces and motion. So first formula here is speed is equals to distance divided by time. Then we have formula for acceleration is equals to v minus u upon t. Then we have this three formula, v equals to u plus at, s is equals to ut plus half of at square, and v square is equals to u square plus 2as, where v equals to final velocity, u is equals to, we have initial velocity, s is our distance, t is time, a is acceleration, yes. Now our next concept is distance time graph. This in y-axis we have distance, time, distance, time. This is our distance and this is time. So this graph is for steady speed or constant speed. This is uniform speed, steady speed. Steady speed. This is for increasing, speed increasing. Speed increasing. And this is for distance is constant, it is no moving. Gradient slope 0, gradient 0 at rest. This is at rest. The value of gradient we have in this is this. These are the gradient. These are gradient. Here gradient is increasing from one point to other point. Gradient is increasing. Here we have gradient is constant. So now suppose if the value of this slope here is x, then each and every plot, in each and every plot, this is x and this is y. Everywhere where we will get same slope. Slope is constant. Here we have slope equals to 0. And we have here slope is increasing. Slope increasing. Next is this. So here in this curve we have speed is decreasing. Speed decreasing. So slope is decreasing. This is our distance and this is our time. Then after that we have speed, time, graph. This is our velocity, this is time, this is velocity, this is time. Now suppose this is for constant velocity. Now observe this point. So at this point, this vehicle must have a particular speed. Let us suppose take this 2, this is 4, and this is 6. So from 6 km per hour, this vehicle is moving. It is neither increasing the speed nor decreasing the speed. That's why here we have speed is constant. So speed is constant, that means we have acceleration here is 0. Not this curve. This is our graph for constant acceleration. Constant acceleration. Or we can say it uniform acceleration. Then graph number 3rd. This is steady acceleration. And let's take value is 4 meter per second square. This is also steady acceleration. And value is 2 meter per second square. I have drawn this graph to just make you understand. These both are this uniform acceleration. These both are of line of uniform acceleration, but the magnitude of this vehicle is more than the magnitude of this. That's why here I've written 4 meter per second square, and this is 2 meter per second square. Similarly, if I go a bit downward, then the magnitude is decreasing, and in upward, magnitude is increasing. Then our diagram number 4. This is for retardation, and this we already know, 0 acceleration. Here velocity is constant. Velocity constant. Velocity constant, therefore acceleration equals to 0. And this is for retardation. That means slope is decreasing. And one thing, area under curve of this velocity time graph gives area under curve of VT graph gives distance. And slope gives acceleration. Slope equal to acceleration. Then again we have this Vt, V, this is T, time, this is velocity. So here vehicle is changing gear, changing gear. Similarly this point, and these all points changing gear, changing. This is the point of highest gradient. And here we have, since now this velocity becoming constant, therefore after a certain point, since velocity is constant, velocity equal to constant, therefore we have acceleration equals to 0. Here we have gradient is highest, that means acceleration is highest. Then after we have two more curve. This. This is our velocity, this is time. This is velocity, this is time. So this is, say this is a VT curve and this is a straight line, therefore this is of uniform acceleration. Uniform acceleration. Because slope of VT curve gives acceleration. The slope of VT curve gives, suppose this is y and this is x, therefore slope will give acceleration. So here we have uniform acceleration when a falling stone with no air resistance. Now suppose if stone is falling with no air resistance, then this would be a curve or diagram for that particular case. When a stone is falling with no air resistance present, and when air resistance is present, then our curve will be like this. This is non-uniform acceleration. This is non-uniform acceleration. Of falling stone when air resistance is acting, when air resistance acting. And this is uniform acceleration, when no air resistance. Then we have our Newton's first law. According to your book, because we can define Newton's first law, second law and third law by many ways, but whatever given in your book, I am just stick on your book and nothing else. If no external force is acting on an object first, if no external force is acting on an object, therefore first, if object is stationary, then it will remain stationary, then it will remain stationary. And second, if object is moving, then it will keep moving. That's it. Listen, since हमारे पास टाइम बहुत कम है, that's why I am not making you to understand these concept. अभी मैं जो है साफ क्लियरली सिर्फ लिख दे रहा हूँ कि what न्यूटन फर्स्ट लॉ सेज और what न्यूटन सेकेंड लॉ सेज और न्यूटन थर्ड लॉ सेज. अभी हमारे पास उतना टाइम नहीं है कि हम कॉन्सेप्ट को डिस्कस कर सके, बिकॉज दिस इज योर लास्ट टाइम रिविजन लाइक समथिंग, कि आप जस्ट इसे खोलो और डिफरेंट डिफरेंट जो फॉर्मूलाज वगैरह हैं उसे आप पढ़ लो, और फिर कुछ कुछ कॉन्सेप्ट्स भी मैंने इसमें डाला है. Then we have Newton's second law. In your book, they have written simply the relationship between force, mass and acceleration. Forces, mass and acceleration. That's it. Therefore, F equal to mass into acceleration. This we got from Newton second law. इसके अलावा हमें कुछ नहीं जानना है इससे. Then we have Newton's third law. It says that every action there is an equal but opposite reaction. Therefore, FAB is equals to minus of F this B FAB. Therefore, we can say F of AB is equals to F of BA. Here the magnitude of forces are same, but this negative represents they are acting in different direction. Then we have one simple definition, 1 Newton resultant force acting on 1 kg produces an acceleration of 1 meter per second square. This is 1 Newton force. Next we have a dynamic friction, D-Y-N-A-M-I-C. Dynamic friction is always less than equal to static friction. Then we have point next, air resistance is a form of dynamic friction. Then the wheel is mounted on roller bearing to reduce friction. So these are some of the important points which are given in your book. I have directly taken from your book only. बिकॉज एज आई ऑलरेडी टोल्ड, अभी हमें कॉन्सेप्ट पे ध्यान नहीं बल्कि मार्क्स पे ध्यान देना है, किस तरीके से हमें ज़्यादा से ज़्यादा मार्क्स आ सके बोर्ड एग्जामिनेशन में. सो दिस इज योर, आई मीन लाइक लास्ट टाइम रिविजन टाइप समथिंग आई एम गिविंग यू. Then weight equals to very simple mg, where m is the mass and g is gravity, and g we take as 10 meter per second square. Then we have concept of this momentum in this chapter. So momentum equal to mass into velocity. Momentum is equals to mass into velocity. Then we have relationship between force and momentum. Force and m is for momentum. Therefore resultant force equals to change in momentum upon time. Change in momentum upon time. Therefore F equal to, we can say, change in momentum m, mass, final velocity minus initial velocity, this upon time. Then we have impulse is equals to force into time. Impulse is equals to force into time. So force into time, we can write impulse. Therefore impulse is equals to change in mv minus, this is u. This impulse equal to, we can say, mv minus mu. Now one last concept we have remained in this chapter, that is the concept of centripetal force. centripetal force. Centripetal force, it is an inward force. It is an inward force acting towards center of the circle. Now suppose this is a circle. I'm sorry. This is, we have circle. So inward force is like this, 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 this. Force acting toward the center. This type of example is observed in planet around the sun. Planet around the sun. Then elements around nucleus. So guys, this is all for right now.